Hello, everyone, and welcome. Today, we're taking a really essential academic deep dive into Chapter 8 of our software engineering text. We're going to focus specifically on user testing, and then we'll bring the whole thing together with a master summary. We're going to explore exactly why testing a program perfectly in a developer's lab is, well, it's simply never enough to guarantee it's going to work in the real world. For a professional software engineer, that distinction is absolutely crucial.
Okay, let's dive into this. Here's exactly how today's explainer is going to unfold. First up, an intro to user testing. Second, we'll cover the 3 types of testing. Third, the acceptance testing process. Fourth, we'll do our Chapter 8 master summary. And finally, we'll wrap up with the final exam focus.
Section 1. Intro to User Testing.
Right, so this is the crucial moment in the software development lifecycle where we shift our focus away from the developer's beautifully controlled laboratory and out into the wildly unpredictable real world. To really grasp why developer testing just isn't enough on its own, imagine we're building a complex software system for a busy hospital ward. In the developer's lab, the program runs perfectly, the inputs are clean, the Wi-Fi never drops, and let's be honest, the developer probably thinks their code is completely flawless. But the real world? A hospital ward is absolute chaos. You've got sudden patient emergencies, doctors having critical conversations, constant interruptions, alarms going off. A lab environment can literally never replicate that kind of operational chaos or the completely unpredictable human behavior that comes with it. And that is exactly why we need users to test the system in their actual day-to-day environment.
Section 2. 3 types of testing.
So, the crucial point here is that since we can't perfectly replicate the real world in a lab, the industry has established a core taxonomy of user testing broken down into 3 distinct stages. Stage 1 is alpha testing. By definition, this is when a small, hand-picked group of software users works super closely with the development team to test early and, frankly, often unfinished releases of the software. Because the users and developers are sitting there working together side by side, they can catch all those non-obvious issues that developers just wouldn't spot on their own. You'll see this all the time in agile development, where user feedback is just constantly rolling right into the next iteration of the software.
Moving on to the second stage, we have beta testing. This is where a release of the software is finally pushed out to a much larger, often completely public group of users, your early adopters. The whole goal here is to let users experiment with the software in their own diverse, totally unconstrained environments. Because think about it, product developers can't possibly anticipate every single hardware setup or weird operating system setting their customers might be using. So beta testing is just essential for discovering those unexpected interaction problems. Plus, as an awesome added bonus, it usually serves as early marketing to build hype for the product.
Let's just pause for a second and contrast these two to really lock in your understanding. Alpha testing is essentially an internal affair. It's closely monitored, highly controlled, and users are directly collaborating with developers. Beta testing, that's external. It's unleashed into the wild, diverse public environments where developers have absolutely no control over how the software is being used. Making sure you understand the difference between these two is key before we jump into the final and honestly, probably the most high-stakes stage of custom software testing.
And that final stage is acceptance testing. Think of this as the ultimate hurdle for custom software. Acceptance testing is the formal process where the customer actually takes the custom system, plugs in their own real-world data, and decides whether or not to officially accept it from the developers. It answers the biggest questions of all. Does this software actually meet our real needs? Is it fully ready to be deployed? And critically, should we pay the developers their final bill?
Section 3. Acceptance Testing Process.
Okay, get your pens ready, because we're going to break down the procedural mechanics of how this actually works, and you'll want to take methodical notes. This process brilliantly illustrates a highly structured, sequential flow. It starts right at the beginning with defining the testing criteria and flows all the way through to that final, massive decision to either accept or reject the system, complete with feedback loops if the testing reports show we need a bit more negotiation.
Let's methodically walk through these exactly 6 stages. Stage 1 is define criteria. Now this should ideally happen way early on, even before the contract is signed, so everyone knows exactly what constitutes an acceptable system. Stage 2 is plan testing, where we hash out the resources, the time, the budget, and the schedule. Stage 3 is derive tests. This is where we design the specific tests to check both the functional and non-functional characteristics of the system. Stage 4 is run tests, the actual execution phase, which really should happen in the true operational environment. Stage 5 is negotiate results, where we sit down, look at the problems found, and figure out how to resolve them. And finally, Stage 6 is reject or accept, where developers and customers look each other in the eye and make the final call on deployment.
Now, I really want to expand on that fifth stage, the negotiation stage. There's a huge misconception among students that acceptance testing is just this strict binary pass or fail, like one bug and the whole project is binned. No way. The reality of professional software engineering is so much more nuanced. Customers usually want to start using the software immediately to recoup their massive investments, even if a few minor bugs are still hanging around. So they often agree to what we call conditional acceptance. This means they officially accept and deploy the system for their daily work, but under the strict contractual condition that the developers promise to fix those remaining minor bugs as quickly as possible.
So, you might be wondering, how does this whole formal process look in Agile development frameworks like extreme programming? Well, it's completely different. In Agile, there often isn't a separate grand acceptance testing phase tacked on to the end of the project. Instead, an end user is literally embedded right into the development team as an ongoing alpha tester. The requirements are defined as user stories, and the tests to check those stories are fully automated. The team literally doesn't move forward until those automated tests pass. But, a quick word of caution, a major drawback here is that one single embedded user might not actually represent the true diverse behavior of all your users out in the real world.
Section 4, Chapter 8, Master Summary.
Now that we've covered the specifics of user testing, it's time to synthesize these broad concepts so you have a solid, holistic view of the whole chapter. But before we do, what's really interesting about this next point is that we must acknowledge a fundamental, undeniable truth of our discipline. Edgar Dijkstra famously stated way back in 1972, testing can only show the presence of errors, not their absence. Let that sink in for a second. No matter how many hours we test, no software engineer on Earth can ever logically prove that a program is 100% defect-free. We can absolutely prove that bugs exist, but we can never, ever guarantee that we found all of them.
Keeping that humility front and center, let's run through our micro recaps of the chapter. First, development testing. This is done by the developers themselves to find bugs, and it scales up from unit testing individual methods to component testing related objects, all the way up to system testing the integrated whole. Next up, test-driven development, or TDD. This is that fascinating practice of writing your executable tests before you even write a single line of code. It relies heavily on automated regression testing to make sure new changes don't accidentally break old features. And lastly, release testing. This is a black box validation process done by a totally separate, independent team to ensure the system meets requirements under various scenarios, including intense stress testing to see exactly how the system fails when it's pushed to the absolute limit.
Section 5. Final Exam Focus.
All right, everyone, listen up. This is the highest yield section of the explainer. What absolutely must you remember for the exam? If you've drifted off, grab a coffee and come back to me right now, because you need to highlight this in your notes.
Here are your top priority, high-yield facts. Number 1, you must be able to clearly differentiate between alpha, beta, and acceptance testing. You need to know who is testing the software, where they are testing it, and why. Number 2, you must memorize all 6 stages of the acceptance testing process, and you need to know them in exact chronological order. And number 3, understand the concept of conditional acceptance, and be able to explain why acceptance is rarely just a strict pass or fail binary. If you can master these points, along with our broader chapter summaries, you are going to be in fantastic shape. Honestly, congratulations on mastering the principles of software testing up to this point. It is such a vital, non-negotiable skill for any professional software engineer.
I want to leave you with one final provocative thought to ponder as we officially close out Chapter 8. If, as Dijkstra rightly said, testing can never prove the absence of errors, how do we go about building resilient systems in an increasingly complex world? How do we intelligently design software that actually survives the bugs we inevitably didn't catch? Think deeply about that as you prepare for the next frontier in your software engineering journey. Thank you so much for joining me in this explainer, and I will see you all in the next lecture.